Welcome to the debate. Today we're diving into, well, a really fundamental question about how we understand reality. It's about the intricate relationship between what we perceive, what we see and hear, and the conceptual frameworks we bring to that perception.
Right, and this isn't just some abstract philosophical puzzle. It genuinely underpins how we learn, how science even happens, and ultimately our grasp on what we might call objective truth.
Exactly. So the central question we're grappling with today is this. To what extent does our prior conceptual framework, our existing ideas and theories, fundamentally determine what we perceive? Or is perception a more distinct, foundational input that our intelligence then has to work on and transform? I'll be arguing that what we perceive is deeply, almost, inextricably linked to our existing conceptual models and expectation.
And I'll be taking the position that perception, while obviously crucial, provides a more, let's say, rudimentary and often quite fallible input. It's something that really needs sophisticated intellectual operations, higher-level thinking, to be properly understood and organized into coherent knowledge.
Okay, so from my perspective, perception isn't just this passive reception of data from the world. It's profoundly shaped by our existing conceptual frameworks, or what Thomas Kuhn famously called paradigms. Think of a paradigm as that sort of dominant theoretical framework, the worldview that shapes how a scientific community, or even just an individual, understands reality at a given time. What someone, especially a scientist, sees, it isn't raw, neutral input. It's a phenomenon that's already structured, already given meaning by their prior training, their theoretical commitments. We see this play out so clearly throughout the history of science. When these dominant paradigms shift, scientists literally begin to see the world differently. Let's take the understanding of light, for example. It's evolved dramatically, right? Newton saw light as tiny corpuscles, like little particles. Then Young and Frizzell, through their experiments, convinced the scientific community to see it as waves, like ripples in a pond. And then much later, quantum mechanics introduced photons, which have this bizarre dual nature, both particle and wave characteristics. Now, each of these paradigm shifts didn't just change how physicists interpreted their observations, it changed what they actually sought out, what they looked for, and what they perceived as evidence. It changed the phenomena they registered.
Okay.
A really compelling illustration, I think, is William Herschel's observation of Uranus. When he first spotted it, astronomers working under the prevailing categories of the time perceived it as just another star or maybe a comet. Those were the boxes they had. It was only after a relatively minor shift in astronomical understanding, a change in their conceptual framework, that it was seen as a planet. And this recategorization wasn't just sticking a new label on it. It fundamentally altered how it was perceived, how it was studied, and it even paved the way for discovering asteroids later on. Similarly, Galileo looked at a swinging stone and saw a pendulum, a system with predictable, measurable oscillations. Aristotle, though, operating within a completely different physics, a different framework, perceived the same event as constrained fall.
Galileo's genius wasn't just in his measurements. It was in exploiting the new perceptual possibilities that these evolving theoretical shifts made available. He saw the same thing, perhaps, but his framework allowed him to organize and understand that sight in a completely novel and ultimately more fruitful way.
Mm-hmm.
And even in psychology, you see this. Experiments involving anomalous playing cards, like a black 4 of hearts or a red 6 of spades, or experiments with inverting lenses that turn the world upside down, they show this principle really clearly. Subjects often struggle to even see the anomaly, the black heart, until their conceptual expectation is sufficiently challenged or broken down. These experiments demonstrate how perceived qualities, even basic ones like size or color, can vary profoundly with a subject's prior training and expectations. And what's really interesting, I think, is that even an anomaly, something unexpected, can only be recognized as an anomaly if we first have a clear expectation, a precise paradigm-induced expectation for it to violate. Our perception isn't just passively receiving information, it's actively filtering and structuring it based on our conceptual toolkit.
Okay, I appreciate that strong argument for the deep influence of paradigms on perception, and I absolutely agree that our minds are anything but passive receivers. However, I come at this from a slightly different angle. While perception is undeniably crucial, it's our initial point of contact with reality, I'd argue that it constitutes a more immediate, direct, and, importantly, often distorting form of knowledge. It's fundamentally distinct, I believe, from the higher-order, irreversible operations of intelligence. Perception gives us that initial sensory input, yes, but it's inherently limited. It doesn't on its own possess the systematic, objective structure that intelligence actively works to construct and refine.
Okay, so you see a sharper divide.
I do. The influential psychologist Jean Piaget, for instance, he defines perception quite specifically as knowledge we have of objects or of their movements by direct and immediate contact. And he sharply contrasts this with intelligence, which he says involves detours, mental steps, operations, and increasing spatiotemporal distances. Meaning, intelligence allows us to think about things far removed in space and time, to reason abstractly. This highlights for Piaget a really qualitative difference. Perception is bound to the immediate sensory input, whereas intelligence transcends it.
Right.
And Piaget identifies what he calls a fundamental contradiction between the rigidity of a perceived configuration, how things initially appear to us, and the reversible mobility of operations, the flexible thinking of intelligence. What he means by that, essentially, is that how we perceive things initially, that configuration, is often fixed. It doesn't easily adjust or combine with other bits of information. Perceptual structures are described as irreversible and non-associative, and they're characterized by a kind of distorting relativity. So perception, left to its own devices, often fails to fully combine information or compensate for changes, leading to inherent biases and illusions.
Can you give an example of that?
Sure. Take Delboeuf's illusion. That's the one where you have two identical inner circles, but they appear different in size depending on the size of the outer circles surrounding them. Visually, it demonstrates how perception can subjectively exaggerate objective differences or similarities. It illustrates this lack of compensation and the non-combinative character of perceptual relations. Our eyes and brain don't automatically, do the math and adjust or undo the illusion based on the context. Similarly, Weber's law, which explains differential thresholds, like how much heavier does an object need to feel before we notice the difference, it reveals how perception often accentuates contrasts. This can lead to what Piaget calls illusory similarities or illusory differences, which are quite distinct from the objective, measurable relativity that intelligence can achieve through comparison and calculation.
Okay.
And we see this very clearly in cognitive development. Children's early intuitive thought is initially closely modeled on perceptual data. It is quite simply pre-logical. It's characterized by what Piaget called centering, where they focus on only one striking aspect of a situation, like maybe just the height of a liquid column in a glass, while totally ignoring its width. And this leads them to make incorrect judgments about, say, the conservation of quantity. They think the taller, thinner glass has more liquid. True operational understanding, the kind that enables classification, putting things in order, seriation, and understanding transitivity, like if A is shorter than B and B is shorter than C, then A must be shorter than C. That develops later, and it develops through a gradual decentralization, a process of overcoming those initial perceptual biases.
It was actively constructing an understanding that transcends the limitations and distortions of just raw perceptual input.
I appreciate your framing of perception as this direct, often distorting input that intelligence then has to sort of clean up and refine. But I wonder if we're not just talking about reinterpreting fixed data here. My argument leans more towards a fundamental transformation in what we can even perceive as reality in the first place. When we talk about the distinction between seeing and constructing reality, I'd really emphasize that paradigm shifts aren't merely reinterpretations. They feel more like transformations in how reality is fundamentally experienced.
Experienced. Okay.
Consider Lavoisier again. He was actively looking for alternatives to the phlogiston theory of combustion. He was, in a very real sense, prepared to discover oxygen. He could see it, or rather interpret the experimental results as oxygen. In experiments where Priestley, who was still deeply committed to the old phlogiston paradigm, simply couldn't. Priestley saw something else entirely, dephlogisticated air. This suggests that the metaphor, the scales falling from the eyes, it might actually reflect a genuine reorganization of perceptual experience itself. The world of the scientist, as Kuhn put it, has come to be populated with planets and pendulums as fundamental ingredients of their immediate experience. There's no sort of hypothetical fixed vision, no neutral data stream independent of a paradigm that we then logically operate on. The very given, the input itself changes, not just our interpretation of it.
Right. I understand the power of that paradigm shift idea and the notion that our conceptual frameworks deeply inform what we experience. However, I'm still wondering, how does your view fully explain the progression we see in children? That move from what Piaget called egocentric perception, seeing things only from their own viewpoint, to a more universal, decentralized understanding. Is that also just a paradigm shift, maybe a developmental one? Or is there a distinct cognitive development happening there, where the underlying organization and, crucially, the correction of sensory input becomes the domain of an active developing intelligence? The initial poverty of results from introspection and early thought psychology, like the work by Binet and Marbe, they struggled to find constant conscious states linked to judgment. It suggests that there's some underlying, non-perceptual, logical factor at play. And we see this developmentally, don't we? Children eventually can infer equalities like understanding A equals C, even if they derived it from A equals B and B equals C, even when, perhaps, they might still perceptually see C as looking slightly different from A due to some illusion or bias. This indicates that operational thought, their developing intelligence, actively reconstructs and reorganizes the perceived information. It moves beyond just passive apprehension to a structured understanding. It's not that they suddenly see the equality perfectly, perhaps, but they deduce it. They know it through these higher cognitive functions that aren't completely shackled to the immediate visual input.
That's a crucial point about development, and I certainly agree that our understanding, it clearly evolves and becomes more sophisticated. But my concern with separating perception and intelligence quite so sharply is that your perspective might still implicitly rely on the idea of a neutral observation language, or some kind of objective given data that exists independently of any conceptual framework. And I find that idea increasingly difficult, maybe even impossible to maintain. The philosophical attempts, over centuries to secure an experience fixed and neutral, or to treat scientific theories as just man-made interpretations of given data, they've largely run around. They become, as some have argued, frankly, hopeless. Our shared ways of seeing, the exemplars Kuhn talked about, the group-licensed ways of perceiving reality that we learn, these are products of our paradigms, and they seem to preclude any pure, unmediated perception of reality.
Okay, I take your point about the difficulty of isolating pure data.
So, from that standpoint, what counts as objective reality is intrinsically tied to the prevailing paradigm. When paradigms shift, the fundamental structural elements of which the universe is composed, as Kuhn says, can also seem to change. Think about the profound differences between Newtonian and Einsteinian physics. Their concepts of mass, space, time, they don't just different interpretations of the same underlying phenomena. They represent entirely different foundational understandings of reality itself. It's not that Newton and Einstein see the exact same universe and just applied different mathematical rules to it. In a very real sense, they inhabit different conceptual worlds, and their perceptions, their expectations of what they will observe, are aligned with those worlds.
That's a compelling argument, and I certainly agree that the idea of a purely neutral observation point is, highly problematic, maybe illusory. But even if initial perception is deeply centered, maybe even egocentric, as Piaget put it, isn't the whole point of cognitive development, as Piaget describes it, to move beyond that limitation? The development of what he called operational groupings, logical structures in the mind, leads eventually to a complete decentralization of thought. Now, I'd argue this isn't just adopting a new paradigm. It's a fundamental structural transformation in thinking itself. It allows for the coordination of all the different viewpoints in a system of objective reciprocities. This is what ultimately allows us to achieve conservation, understanding that quantity stays the same despite superficial perceptual changes, and to reach a mobile equilibrium in our thought. A state that fundamentally transcends individual, subjective, and often biased perceptions. And look, the very existence of an irreducible character in formal connections, think about basic axiomatic logic or mathematical principles, these provide a kind of normative framework. It's almost like a universal mental architecture that guides the mind towards a more stable, coherent understanding of reality, one that goes beyond what any single individual might happen to perceive at a given moment. This implies that while our initial perceptions may indeed be flawed, perhaps paradigm-influenced, as you say, intelligence possesses the capacity to construct an increasingly objective understanding through these reversible and systematic operations. It allows us to move beyond just competing worldviews towards something more universally applicable, more rationally defensible.
So we've touched on how perception and intelligence interact in basic observation and even shaping our notion of objective truth. Let's shift our lens now, just briefly, to a different but equally crucial area. How does this dynamic play out in the process of learning and development itself? If our frameworks are so powerful, as I argue, what role does pure raw sensory input really play in learning? Is it just a passive canvas our paradigms paint on, or does it actively push back? From my perspective, learning, particularly learning in science, is characterized by acquiring from exemplars the ability to recognize a given situation as like some and unlike others. This isn't just about memorizing facts or rules. It's about forming a time-tested and group-licensed way of seeing.
Okay.
This process, which is heavily influenced by education, by culture, by the scientific community you're part of, it profoundly conditions the route from stimulus to sensation, the actual pathway. The knowledge embedded in this stimulus to sensation route is often tacit. As Michael Polanyi would say, it's not always accessible through explicit rules or generalizations that you can write down. Yet it profoundly shapes what is immediately perceived, what jumps out at you as significant, and what might be ignored. We learn how to see through the lens of a paradigm, and that learning literally changes what we perceive as immediately relevant or even existent in the world around us. It's not about passively absorbing facts onto a stable perceptual base, but actively developing the very capacity for perception within a given framework.
I appreciate that perspective on learning as acquiring a way of seeing, but I find myself needing to push back a bit on the idea that it's solely a group-licensed way of seeing. My concern is that framing it that way might overlook the active internal construction that allows for genuine intellectual development, which I believe transcends mere perceptual conditioning or adopting a group view. Development, from my standpoint, and drawing again on Piaget and others, is characterized by distinct stages. Think sensori-motor, symbolic, intuitive, concrete operational, formal operational. Each stage involves a qualitative leap, not just more information, but actively transforming previous ways of understanding and, crucially, overcoming the inherent limitations of earlier, more perception-bound thought.
Right, the stage theory.
Exactly. Take the child's struggles with those conservation tasks again. At the intuitive stage, they might judge the liquid quantity based solely on the height of the column, completely ignoring its width. This is a classic example of perceptual centering being captured by one salient feature. Their thought is pre-logical at this point. It represents an incomplete intellectual construction, precisely because it's so tightly tethered to immediate, potentially misleading perception. It is through active equilibration, this is Piaget's term for the process of self-regulation, adjusting mental structures in response to environmental feedback and cognitive conflict, and through repeated regulations, that the child gradually constructs the reversible combinativity that characterizes operational intelligence. This is what allows them to mentally pour the liquid back or consider both height and width simultaneously.
This journey towards a more robust, more objective comprehension is distinct from, and indeed has to overcome, the immediate and often distorting inputs of raw perception. It's an active process of intellectual construction
not simply learning a prepackaged way of perceiving handed down by the group.
Indeed. Well, I think both our perspectives tonight underscore the profoundly active nature of the observer in engaging with the world. We've certainly moved far beyond any simple idea of passive reception of sensory data. We clearly agree that we're not just, blank slates taking impressions. But our discussion today has really highlighted how these insights diverge quite significantly on the nature, the origin, and the integration of this activity with our conceptual understanding. My view, as we've explored, suggests an almost seamless, paradigm-driven construction of perception, where our frameworks don't just influence, but in a deep sense define what we actually see.
And my position, in contrast, highlights more of an intellectual ascent. One where perception serves as that raw, sometimes flawed, often imperfect starting point. A starting point that is continually refined, transcended, and objectively organized by a developing active intelligence. It's the capacity for operational thought, with its hallmark characteristics like reversibility and combinativity, that allows us to systematically move beyond the inherent limitations and distortions of raw sensory input, pushing us towards a more stable, coherent, and ultimately more objective grasp of reality.
Absolutely. And this discussion, I hope, illuminates not just the mechanics of how we see, but how we actually come to understand. It really invites us all to reflect further on this incredibly intricate interplay between direct sensory experience and our powers of intellectual construction, informing our knowledge of the world. It's a dynamic tension, isn't it, that continually shapes our reality.
Precisely. There is clearly much more to explore and to unpack in this rich interplay between the immediately given, the perceptually filtered, and the intellectually constructed aspects of our reality. It's a fundamental puzzle, really, that continues to challenge our understanding of knowledge itself.